So today we're going to graph cosecant and secant, and it's really rather simple if you know how to graph sine and cosine, which from your quiz scores, those of what I've gotten through, you have a pretty good handle on, so that's good. You need to know these four things to graph cosecant and secant. If you can graph sine and cosine, Christian, then we can graph secant and cosecant. The other thing that you need to be fully aware of, what are inverses of each other? So if we're going to graph cosecants, cosecant is the inverse to what? The sine. So we would graph the basic sine curve, and we're going to do a couple of things to it. And then if I'm going to graph secant, what's the inverse to secant? Cosecant. What did you just say? Cosine? Yep. And so, if you know those, we're going to be good to go. So step one says graph your basic sine or cosine. So as I'm graphing, for instance, y equals cosecant of theta, just plain cosecant of theta, no amplitude, nothing in front of theta, so there's no period change, no addition or subtraction in here, so there's no up, down, or right, left movements. It's just a plain cosecant. If I plot a plain sine, we can get cosecant. So that's what the first step is asking you to do. And then the second two steps will make sense once you look at the graph. Any minimum points of the sine or cosine graph become maximum, and vice versa. Any maximum points of the sine or cosine become minimums. And then wherever the points are not max or min, and you'll see what that is in a minute, those will become asymptotes. And as we found out yesterday, asymptotes are where the graph is undefined. Where would cosecant be undefined? When what is what? What makes this ratio undefined? When sine is 0. So wherever sine is 0, cosecant is going to be undefined because it will give a ratio where 0 is anytime. So we'll look at that on the graph. So look here, period is back to pi, or 2 pi, because we're graphing out of sine and cosine, and so it makes sense that that would be the period. Our range on here is incorrect, so cross that out. When we graph it, I want you to tell me what the range is. And so let's just go ahead and graph a plane. Inverse is sine. So we're going to graph a plane sine. So I'm going to take and partition this as we have been doing. I choose to go by quarter pies because it stretches things out a little bit. That means I just have less multiples to do. I'm going to make this be 1 and this negative 1. So then you're going to take a different color, or at least dot it really lightly with your pencil. You're going to graph sine. Don't connect the points, but sine normally starts at 0. Then it goes up, 0, down to negative 1, and back to 0. And so if I dotted that, that's one sine wave, agreed? And as you can see here, or would you agree with me that this is a maximum of the graph? True or false? So this max is going to become a min. I'll show you how to do that. And wouldn't that be a minimum of the graph? Lowest value? That's going to end up being a maximum. And I'll show you how in just a minute. They're really relative max and mins, but we won't stress over strict vocabulary. Those points are neither max nor min. They are what? X-intercepts, they're zeros. And so up here, that's what we're looking for. Points that are not max or min are asymptotes. And that would be the zeros. So wherever there's a 0 of the function, we get these asymptotes. And with sine, there's always 3 zeros in one period. So the first asymptote is right here at x equals 0. The vertical line going through the x-axis at 0. So that's asymptote number 1. And then over here at pi, we have another 0. So that would be x equals pi. So that's asymptote number 2. If I ask you for the graphs of the asymptotes, there's an infinite number of equations you could give me. These are just the first ones that we take off of the general sine graph. And so you can give me whatever increments of pi that you wanted to. It's just a lot easier to know these. And besides, you're going to make them up from your graph anyway. I don't teach how to find them mathematically, but graphically. So, step 2 says make any minimum points a maximum. So here's my minimum point. To make it a maximum, I'm going to take a different color. And the graph is cut right here. So you can cut the sine wave right here because it can't cross that asymptote. Doesn't this look like a parabola? It's a parabola opening up. So make it go in the opposite direction. We're going to make a parabola opening down, hugging those asymptotes. So that's what it means to make a min into a max. Now that's the maximum of the parabola. And then same thing here. This maximum is going to be from the minimum. Just flip it. So now you have this alternating pattern of up and down parabolas. This represents one full period of cosecant. It's cosecant and secant are the only the only ones that you're going to look at that have a break within the period. So our period is still pi because the pattern doesn't repeat. Well, it repeats every 2 pi. Up and then down. That's one repeat pattern. So from here, you need to put in your asymptotes at every pi to finish out the pattern using a straight edge, of course. And then don't forget to continue your pattern of points. You cannot just do up and down parabolas without the proper points because you'll lose half your points for your graph because that's the accuracy of your graph. So you can choose to connect these points with a dashed line if you want to, but once you have the pattern of up-down parabolas from the first period, there's really no need to, but some of you, it helps. So you go ahead and you can jot that in. I'm not going to. This one is down, then this one is up, this one's down, and this is a partial up. This one's down, and this is a partial up. So then what is our range? It's the lowest possible value here. Negative infinity. So we start at negative infinity and we go to what value? Negative 1. Do we include negative 1? Is it a point on the graph? Yes. It's a point on the graph. So we do include it, union. And then we make a leap and land where? At 1. Do we include 1? Yes. I'm going to go to positive. So that's really good. And as you can see, your vertical asymptotes are going in the pattern of multiples of pi. Any questions on that? Okay, so this is really important that you find your zeros, which are your asymptotes. They're part of the pattern. And then plot your sine curve or your cosine curve, and that gives you your max and min points of where you're going to open up or down. All right, flip it. Let's do secant. So secant's going to be done identical to what we just did, but secant is the inverse of what? The inverse is cosine. So instead of graphing secant, well, we are going to, but I'm just going to graph cosine. But I'm going to pay attention to any changes in amplitude, period, any up, down, or right, left changes. This is just plain secant. None of those changes are occurring. So we're going to start with our normal partitioning because I know I don't have a period change. I don't have an amplitude change. I don't have a right, left, or an up, down movement. Then my vertical axis, I'm going to make this 1 and this negative 1. So plot a regular cosine wave. So cosine starts up at the amplitude, and my key points have not changed from the unit circle. So up at the amplitude, 0, down to the amplitude, 0, and back up. And so if I dash this, cosine's a little different in the respect that we only have 2 zeros. That's where our asymptotes go. So those are our first 2 asymptotes. And since this is halfway in between 0 and pi, going through the x-axis, is x equals pi over 2. So there's one asymptote equation. And this is going up through 3 pi over 2. The problem with this is, I mean, you can do it from here. I've got a minimum, it's got to become a maximum. And then I have these half ones. So it'd be nice if you just added an extra asymptote on either side. Same distance as the first 2. And you finish off that curve a little bit. And then you can see that this is really what a full period of cosine would look like. Inversed into secant. So it looks exactly like cosecant, but the asymptotes are in different spots. And so you're going to finish out all the asymptotes. The asymptotes end up being directly in between each multiple of pi. And then you must put in your pattern of points. And it's a nice check because every time you hit the 0 line, you should be on an asymptote. And then you could dot that line or not. You should be able to see the pattern of up-downs. You will never see up, up, down, down. So this time, because we're starting our first asymptote at pi over 2, we start at pi over 2 and then add full increments of pi after that. Period is still 2 pi, but our range is wrong. What's the range? It's the same as the last one, right? So negative infinity to negative 1, bracket, union, bracket 1 to positive infinity. So don't graph number 6 yet, because I'm going to change the question on you. Any questions on that before we do more complicated questions? Those are just plain basic graphs. Okay? All right, so we're going to change example 6 to read y equals 3 secant of 2x. What did I put? Minus 1. So we have 3 things going on here. Same thing, first of all, it's secant, so what is it the inverse of? Cosine. I could have easily given you the same equation, but put cosecant in there, and everything would be identical with the exception of your pattern of points and obviously your asymptotes are going to be in a different place. But the process is still the same. What is your amplitude? Amplitude is 3. So remember, the amplitude implies 3 above the 0 line and 3 below the 0 line. The 0 line could change from the x-axis. Is there an up, down, or right, left movement? Yes. Where?
Down.
So that negative 1 implies down 1. If it's outside the function, it's sine for sine. So if it's down 1, we're going to move our horizontal down 1, so put a dashed line. I get y, because it's going through the y-axis, y equals negative 1. So my horizontal changes to y equals -1. Is there a vertical change? In other words, I don't mean a vertical change. Is there a change to the vertical axis, a right-left change in this equation? Are there any pluses or minuses inside parentheses? No. So that means that the vertical axis stays the same, and it remains x equals 0. Is there a period change?
Yeah.
Is there a coefficient in front of the x? Yes. So there's a 2 in front. So always we take what?
2 pi.
Notice there's nothing here for you. We take 2 pi, always 2 pi because that's the normal period of cosine. And we're going to divide it by whatever the coefficient is in front. In this case, 2 pi. Don't we get an answer of pi? So our period has done what? How? Horizontal shrink. We've gone from 2 pi to pi. So you have a horizontal shrink. Immediately, you want to find your key points. So take that pi over that pi. Take that pi and always divide it by 4. That does not reduce. So our key points are going to go in increments of pi over 4. So immediately, because I know my increments, my denominator is 4, I'm going to divide this into 4s. In other words, every grid line is going to be worth a 4. And so I've got 1, 2, 3, 4. There's pi. 1, 2, 3, 4. There's 2 pi, and so forth. And then I have to find my key points. Since my vertical axis did not change, what is my first key point? It's the cosine. It's always 0. Because I didn't have a vertical change, so there's no need to do that start or end. So then I'm going to take my increments and I'm going to add pi over 4 each time. And so I get pi over 4, add pi over 4, I get 2 pi over 4, you can leave it unreduced. Add pi over 4. I get 3 pi over 4. And one more time, add pi over 4. I get 4 pi over 4, but I choose to write that as mine. So those are my key points. So on my thing here, I'm going to go every single grid line. Something's going to happen. But when I start at 0, 0 is now here at the new 0 line. And I apply my amplitude of 3 above the 0 line. So I'm going to go 3 above, not 2 number 3, but 3 above. So let's partition this out. This is 2, and this is 4. This is -2 and -4. So from here, I'm going to go an amplitude of 3. So 1, 2, 3. This cosine starts up the distance of its increment. And then the next increment is back at the 0 line. This is your new 0 line. So it shouldn't be on the x-axis. And then for the next increment, I'm going down 1, 2, 3, back to the 0 line, and then up 1, 2, 3. So if we dash in, this represents 1 cosine wave. And then I'd like to add in one more, because I know with cosine I'm going to need one more. So wherever, whoops, I just drew that last one wrong, how come? Yeah, it's got to go on the 0 line right here. So I have 2 places technically, and I created a 3rd place where it crosses the x-axis. So if I ask you for the asymptotes, which asymptote would this one be? So it crosses at the new 0, not the x-axis. We want it at the new 0. So wherever it crosses the new 0 line. So what increment is this? X. This is 0. So I want pi's over 4, right? So this is 1 pi over 4. So x is equal to pi over 4. So that's one asymptote equation. And then if this is 1 pi over 4, this is 2, and this is 3 pi over 4. So then the next one would be 3 pi over 4. And then most likely I'm only going to ask you for 2. Technically, give me any 2 that are one right after the other, but those are the 2 I really want. And so then finish drawing in your asymptote, and this asymptote. And you can see, unfortunately, that our asymptotes are quite close together. And I say unfortunately because that means we have a lot more parabolas, so to speak, within that. So our max becomes mins and our mins become max. So this minimum becomes a maximum. This maximum becomes a minimum. And then from here, you can go ahead and put in your asymptotes every 2 grid lines, because that's how far apart they currently are. And then on the left, be careful because you're actually straddling the y-axis. And finally, make sure that you put in all of your points. Don't sketch. No points for sketching. So then make your up and down parabolas. And it looks like the upper parabolas are bigger than the lower parabolas, but that's because we've moved the graph down and we've run out of room down here to show what they really look like. But we can show them equal sizes if we wanted to. So issues, problems, concerns, questions, comments, you feel comfortable being able to do that. Okay. So, I mean, it's really nothing different except instead of actually drawing the full sine or cosine wave, you're cutting at the 0 line, creating asymptotes, and then taking those parabola-looking parts and just flipping them. That's it.